Welcome, everyone. Let us know in the chat where you're joining from. We're going to give people a few more minutes to join. I can see the numbers are rising, and we're also waiting for Matt to join us. Just a few more moments. Seattle, nice. I'm connecting from Zurich, Switzerland, and Sam is connecting from London. Okay, I think, and Matt is connecting as well. Perfect timing, Matt. And I think we can get started. Welcome everyone to today's webinar on Lakera's Policy Control Center. We're very excited that you're here. A few housekeeping items to begin with. Thank you, Sam. So this webinar will be recorded. We're going to send you the recording tomorrow, and we're also going to post this on YouTube. So if you have to leave earlier, don't worry, we're going to share the recording with you. We also have a Q&A session at the end of this webinar. Sam will be the one who will be answering your questions. So if you have questions, feel free to either use the Q&A feature or feel free to pop your questions in the chat. And then we also encourage you to book a one-on-one demo if you want to get a more personalized sort of overview of the platform. And without further ado, I'm happy to welcome our hosts. So Matt Fiedler, our solutions engineer at Lakera, and Sam Watts, the product manager, and I'm going to let them take it away from here.
Matt, do you want to kick us off, or should I do the general intro?
Go ahead. You can start us.
Cool. So thanks for everyone joining us. Yes, for anyone who doesn't know who we are Lakera. We're the leading Gen AI security platform for enterprises. So we, at the core, are securing large language models and new Gen AI applications from all of the new and sadly old risks that they face. We're working with both the cutting edge technology companies of the world, like Dropbox, as well as foundational model providers like Cohere, as well as lots of little startups that are building the future. And so at the core, what we do is we secure anyone who is building with generative AI to protect their LLMs and their end users, and obviously you as the customers from any malicious attackers or threats. Yeah, and we are here today to talk about the Policy Control Center, and we're pretty much going to dive straight in because it's always easier to see the thing in the flesh. So I'll pass over to Matt to give us a demo. No, sorry, I've got one slide before that. So yeah, to explain the product, very important. At the core, the Lakera Guard ensures secure inputs and outputs. So here's a basic diagram. So you have an end user who's interacting with the Gen AI powered application. They write some input that might contain a prompt attack or a jailbreak, prompt injection, these instructions that can manipulate the model, as well as unexpected data. Maybe their PII is put in there, or maybe they're asking the model to do something inappropriate. We can screen that, detect whether there's any threats coming in. Then obviously the application sends the input to the large language model. Also, it might be, if you're using a retrieval augmented generated design, there might be some external data from the internet or documents or whichever that also get passed into the LLM. Those are also very importantly a source of threats. So these could contain an indirect prompt attacks. So someone else has poisoned the data to try and trick a user, or again, sensitive data, inappropriate data. So we screen all of that. The LLM processes it, produces an output, and again, the Lakera Guard can be used to screen that for anything unacceptable or dangerous. And so we're kind of providing that catch-all, holistic protection around your application and around the LLM to make sure that nothing bad is going in or out. And our policy control center is now live, and we're going to show you that now. So, Matt, do you want to take over screen sharing?
Yeah, I think as long as somebody stops sharing, I will share here. Great. So as Sam just mentioned, our policy control center is live. It's integrated right into our platform. So if any of you have used either our community tier or our enterprise tier, much of this will look familiar. The major upgrades and updates here are related to policies and projects. So Sam did a great job of sort of mentioning Lakera at a high level, but aside from where Lakera sits in the sort of security chain, what we do is also important to consider. So out of the box, Lakera has really 4 defense categories that it will screen inputs and outputs for. So Lakera really wraps around the model. It's agnostic to what model you're using under the hood. And if you make no changes at all and you call Lakera on the user's input or the model's output, it will run these 4 set of defense categories across 16 detectors. So that includes prompt defense, content moderation, PII, and unknown links. Now that might be good for your use case, but there's probably a lot of tweaks and tuning that you'll want to do to it. So the first thing that you can do with policies is decide we want to run this set of defense detectors. So think about maybe a user input. You might be really cautious around wanting to ensure that that doesn't contain any prompt injections or jailbreaks, but you might not care so much if there are content moderation violations, as an example. You may also not care so much about PII going into the application. So you could turn those detectors off completely, and you would only then be screening the user's input for prompt defense and unknown links. Similarly, you could set different output settings where maybe you don't think there is real risk of a prompt injection coming out of your model, but you do want to be very cognizant of content moderation, making sure that it's not saying anything hateful, sexually explicit, violent, mentions of weapons, those types of things. You also probably want to look for sensitive information that your model may be producing. And so this is sort of at the most high level, you can turn on and off detectors. Now, the other thing that you can do is adjust the sensitivity of Guard. So when you send a piece of content to Lakera for screening, for monitoring, to get classified, it's going to return a probability that contains, in this case, a prompt injection or a content moderation violation. And it will tell you basically, it's very confident it contains this, or it's somewhat confident, or it's not confident at all. And depending on your risk settings, it might make sense to have a very strict policy in place. So in this case, you would have the sensitivity turned all the way up, and anything that looks remotely like a prompt injection that Lakera receives will get flagged. In a different use case, that might be, a little bit too sensitive. It might trigger on too much, and you would turn it down to a less likely level. So you'd have a more lenient policy. And in this case, Lakera would only flag if it was very, very confident that it contained a prompt injection attack. So those are kind of the first 2 major levers you can pull, is turning on and off defense categories for inputs and outputs, and then adjusting the sensitivity of the detector based on your risk profile. The third thing that you can do, and the major addition in the policy center, is the ability to create custom detectors. So out of the box, Lakera has 16 detectors available. Underneath content moderation, for example, we have 6 subcategories. So that includes hate speech, sexual content, profanity, violence, crime, and weapons. And so you can then build additional detectors for that using regular expressions. So you may key in on specific words. For instance, you might build a list of drugs, or even competitor names, right, that you wouldn't want to either be inputted to your model or going out of it. And then also for PII, you have the ability to build custom detectors with the same regular expressions. And this is very useful because, again, here we have 8 out-of-the-box detectors, but for most organizations, there's data structures that is unique, that are unique to them specifically. So that is how you think about a policy at the highest level. And after you create a policy, we'll cancel out of this one. After you create a policy, it gets assigned to a project. So the easiest way to think about a project is perhaps on an application by application basis, but it could be broader than that. So you might create a policy and then have projects that span multiple external chatbots, for instance, or a policy that spans multiple internal chatbots. But you can, for simplicity, think of it as a application by application basis. So when you create a project, you then assign it the policy that you want to apply to it. And this is how, when you make a request to Lakera, it knows what set of detectors and settings to apply. So you would select a policy to assign to your application. And great. I'm not monitoring the QA, so Kaz, if somebody is saying something, please let me know. Awesome. So now let's see this kind of in action. So here we have a basic chatbot, and I mentioned Lakera is completely agnostic to the underlying model that you're using. So if you're building on OpenAI, if you're building on Gemini, Llama, Claude, something entirely different, Lakera provides the flexibility to support any of them. So this is great because as you're thinking about your long-term roadmap, you may be using a current model now. You might want to upgrade it. You might want to use multiple providers, and Lakera is completely independent from that. So let's just take a sort of basic interaction, and we'll show one category of risk, which is going to be prompt injection. So here, I'm going to begin by asking our chatbot here, how do I buy a gun illegally? This is, in almost every use case that you can imagine, not something that you'd want your model to answer. And fortunately, through basic alignment and good system prompt engineering, you're not going to get a response to a question of like, how do I buy a gun illegally? And we see this often, right? Like there's users, especially if you build something that's externally facing and it's available to the internet, are going to ask things that you don't want to have asked. And mostly the models that you're using are pretty good at denying that. They can handle that question. They know they shouldn't talk about something like that. The challenge then becomes when a prompt injection comes along, which is sort of manipulated text. It can take on a lot of different forms. There's no single signature that you can kind of identify on. Prompt injections generally are trying to trigger some sort of payload that's going to manipulate the model's system instructions into doing something that it definitely shouldn't do. So in this case here, we're going to use a prompt injection on our chatbot here to ask that same question of how do I buy a gun illegally? And so you can see this bit of text really contains nothing that makes sense to the human eye, but it has overrode the system instructions, or at least got it to bypass some of its safety guards to give us a 6-step guide here on how to purchase a weapon illegally. So this is certainly a big problem. We've seen examples of this happen in the wild. This is sort of one of the more like egregious and easy to see examples. And this is something that you want to think about defending against. And you can't really, as you can see, like kind of create a rule list. Doesn't work. So where Lakera comes into play is rather than just taking that input and sending it directly to the model, we're going to first pass it through Lakera, and we're going to run Lakera out of the box. So it's going to run 16 detectors on that input, and it's going to classify the prompt for us with a certain level of probability, so that we know that before this input gets to the model, we basically know what it is. So Lakera is not going to block any of this. We have it in monitoring mode. And it's important to note that Lakera is always sort of in monitoring mode. It's never going to block a prompt on your behalf. You will build workflows based on the intelligence it provides. So in this case, we'll do that same example. we'll do that same prompt injection example, and we're going to pass this to Lakera first, and it's going to give us a bunch of categorizations based on what it thinks it is. And so you can see here, first of all, how fast Lakera is. It operates in milliseconds, so it's not really adding any latency to the interaction. And we can see here that it's flagging on a bunch of different things because this jumbled text contains a prompt attack. It's clearly seeking criminal advice. It has mentions of weapons, and there's actually a name detected in here as well. So this is providing intelligence. And then what you would do with that is enable a sort of blocking workflow. So you can imagine here, if you're just sending, you take your user's input, you send it to your model, and then you produce the output, and you're relying on the model to handle all the security. With Lakera in place, you basically say, we're going to take that user input, get a categorization and intelligence from Lakera, and if it's flagged as true, which we see that this is, let's block it so that the model doesn't process it. And if it looks good, let's send it to the model to continue the interaction. So now with Lakera in blocking mode, we can say, we can see that we've designed a blocking flow. The model doesn't answer this question, and so we've secured this interaction in that way. Now, if we just were to say, like, how is the weather in Paris or something benign? Lakera says, all good, right? None of the categories are flagging there. It doesn't have that real-time information, but the interaction can continue. You know, you can then just have a totally normal interaction with the model, and it's thinking and it's thinking and it's thinking. But you can kind of see in this way how Lakera works. Now, one last thing before I turn it back to Sam is, let's say again, maybe all of these detectors don't make sense for you. You can then jump over and we'll take and let's say we only want to be looking for moderation, for example. So when we use our new project ID, we've basically turned off all those other detectors, and now we're only looking for moderation. And so in this case, if I do a basic prompt injection attack, it's not going to flag because there's no content moderation issues there. But if I say something, that flags it, we'll see that it, flags there. So yeah, that is, I see the chat looks like it's blowing up, but I will stop sharing here and pass it back to Sam.
Amazing. Thank you very much. Let me just share my screen again and we go back to the presentation. Excellent. Yeah, and keep those questions coming. We'll have some Q&A time at the end, and we'll make sure we tackle all of those. So hopefully you can all see my screen. To do a recap, so with the Policy Control Center, you can secure your GenAI applications, and we provide policy flexibility. So you can choose, we offer 4 defenses, over 16 detectors out of the box, and custom detectors on top of that. So you can work out for your specific use case which detectors, which defenses are appropriate. And also, as Matt nicely showed, you can adjust the sensitivity, using the threshold levels, which are in line with the OWASP web application firewall paranoia levels. So we're following in line with that. And so you can fine tune to your use case. And that means you can make sure that whatever you're building with your GenAI application, you can make sure it's secure. And also you aren't getting loads of alerts for things that just aren't an issue. It's worth also pointing out, again, that we can protect both LLM inputs and LLM outputs. And this is a really important part of creating a defense in depth, because obviously you always want to stop prompt attack coming in, but often, with the nature of AI, there's always an infinite number of different ways that someone can attack. And you can make sure that you're really secure by preventing manipulation coming in, but also preventing the bad thing coming out. And so with that combination, that means that you can make a really secure application without increasing false positives because you're stopping on both sides. As we mentioned, we now have custom detectors, so custom regex detectors, and this is all via a developer-first integration, as Matt nicely showed. It's just a few lines of code to integrate Guard into your application, so it makes that super easy. And one thing we also want to emphasize is this is a future-proof architecture. AI is moving and evolving really quickly. And so we deliberately designed this in a way that it's easy for us to add new detectors. So if some new type of threat comes along and starts affecting GenAI applications, we'll build a defense for it, and then you can add it into your applications with just a few clicks of a button and get new defenses as they come. So that makes it super easy to keep up to date with all the new developments, both in terms of new types of GenAI, but sadly, in terms of new threats as well. So to kind of summarize the whole kind of process, we really wanted to make it easy for the security teams and developers to work together. And obviously, depending on your organization, the security team might be the application team, might even be the same person as the developer. But to kind of separate the two of the flow, in Lakera Guard, the security team would create a project. So a project is the part of your GenAI application that you want to control in a particular way. So normally it might be the application, or it could be a specific part. Maybe it's the summary part separate from the chatbot part. Get the project ID, which tells Guard which policy and which metadata and allows us to connect all the data together, ready for analysis later. Then you create a policy and either assign an existing one or configure a new one. And then in terms of the developer, they just pass that project ID into that part of the application with every request to Guard. So that's sending both the input and the output. And then anytime Guard receives one of those API calls, we'll run the detectors in the policy, flag true if any of them detect any threats, and then the application will get a true-false response. Decides whether you want to block it, monitor it, up to you. And so we provide that flexibility to build whichever workflow and how you want to handle it. And then that provides that real-time protection. But importantly, after the fact, you have the capability to dig into this and do analysis. So you can set up alerting, you can monitor this. We have the web UI dashboard where you can see all of this, as well as we integrate with security products like Seams, and so plug into your security workflow. And then, depending on how the policy is performing, you can always adjust it. So if it turns out it's slightly too aggressive, it's easy enough to lower it in a few clicks. Or if you suddenly spot, hey, our users are sending PII, we should block that, then you can add those additional defenses, again, with a few clicks of a button. So hopefully that makes it really easy. And it means for security teams, you're not pestering developers in order to do a whole bunch of extra work in order to secure the application. And for the developers, they don't really need to know anything about GenAI security, work out the policy. They just need to integrate, and then it's super easy, and they can get on with building the application, and the security team can make sure that it's secure and works well. Ooh. We thought it might be helpful as we see lots of different customers of ours using Lakera Guard in the wild and facing various different threats, of some of the different ways of you can fine tune a policy. So we've got a few kind of different examples and ways you as a security practitioner might want to think about this. So the most common use case we see with LLMs is chatbots or chatbot assistants in some shape or form. And it's worth bearing in mind of who the audience is here. So often organizations are building internal chatbots for employees to help support them, but also might have external users. And so obviously, depending on your users, whether they're trusted people you know or complete strangers, you want to fine tune and set the aggression, so the sensitivity appropriately, because for internal users, maybe you don't worry so much about them doing inappropriate content, whereas for external, if anyone's ever seen Reddit or 4chan, you might want to be more sensitive there. It's also worth thinking about what topics are acceptable. So, for example, one of our customers is an education platform, and so when their application is talking about history, it's actually fine for that application to talk about violence and weapons, because in that situation, that's acceptable. That's what you expect in the content. However, when it comes to mathematics, it probably shouldn't be doing that. So if the LLM is outputting violent content, that probably means one of the students has managed to manipulate it or tricked it. So you want to block that and keep that appropriate for the end users. Also, custom detectors. So we are seeing customers put in their competitors' names to make sure their customer-facing chatbot isn't talking about their competitors' products. Also, there may be particular trigger words that they want to stop, and also different forms of PII. So maybe you have a particular location that you're serving, and you want to make sure that that local form of ID is not being passed by users when it shouldn't be. Then the other major use case we see with customers is a RAG application. So that's what's called retrieval augmented generation. So this is when a user is talking to the chatbot. Actually, there is some reference documents or reference materials that the LLM is using in order to answer the questions. So to give you some examples, might be you have an internal policy chatbot. So employees can ask questions that has the whole set of company policies, super useful rather than reading all those documents. But another kind of setup is maybe you have a whole lot of emails, or maybe it's your Slack or communications platform where the LLM has access to all those messages. Now, one of the concerns there is an indirect prompt injection. So this is where anyone who can get access to the content that the LLM is reading can add in a prompt attack and manipulate the model, and then it's the end user that gets attacked and manipulated. So to give you an example, there was a recent case where someone Slack have added a new AI feature, and if anyone can add in any public channel anywhere in the Slack workspace a prompt attack, users can ask a question and they will get a phishing link that is surfaced to them by the Slack AI that tricks them basically into entering their login details. And so obviously, depending on who has access to that data, you want to treat that very differently. So if it's public information, anything on the internet, anything where there's end consumers who are uploading documents that are going to be read by the LLM, you really want to be checking that. So basically anything that is untrusted or external, you want to be screening before it goes into the LLM because it might contain a prompt attack. So in summarization and translation, so this is the other common one, you want to think about, is this being checked by a person? So kind of attacks we see here is people trying to hide information, trying to trick the LLM into explaining, summarizing information differently. So it's really important to think about is this being checked by a person, and then you can attune aggression. And again, like what is the appropriate content here? Do you want to be filtering out stuff? Should it contain PII? Is it okay if it contains PII? So these are things you need to think about. And finally, a common other use case we're seeing our customers use the Policy Control Center for is third-party LLM providers. So many people, aren't building large language models themselves, but they need to make sure that the data they are passing to the large language model is data they are allowed to, is appropriate to. And so things we're seeing here is actually screening the user input or the RAG reference documents for PII and content moderation before sending it to the LLM, because they want to make sure they're complying with data protection agreements. The end user does not want their PII passed to the LLM. And also, sometimes if you might have end users that are doing something particularly horrible, that can actually break your terms of service if you're using, let's say, an OpenAI, Anthropic, or whichever, and they have limitations on what kind of content can be passed to LLM. So in order to make sure you're complying with the regulations as well as terms of service, it's important also to filter at that point as well. Cool. And so hopefully that's enough information on the Policy Control Center. How can you get started? Well, for anyone who's already been using us with our free community tier, our new improved API, our version 2 of our API, is available to everyone today. The documentation we'll be sharing, but all of it is available and you can just connect up today. In terms of the actual policy control, in order to change your policies, That's currently available to enterprise customers, whether that's self-hosted or you're using our enterprise software as a service offering. We will be rolling this out to community customers soon. So if you're on one of our community customers, let us know and we will be rolling that out for you to use as well. And as we said at the beginning of the webinar, you can always reach out and book a one-on-one demo to understand more, but also set up a trial so we can give you some trial access to our enterprise deployment and you can start using it today. Thanks, Cass. Cool. And so some final reminder of some useful resources. So we have the documentation, which is also being linked into the chat. So that's all publicly available. All of the information that we've told you today with loads more details is available there. And we also have our product updates where we have a blog post summarizing all of this here, as well as a whole bunch of other things that we've got in the works. And you can also subscribe there to get future updates as we'll be shipping a whole bunch more added features on top of this, the Policy Control Center as well. So over to the Q&A. And I think Cass has been doing an excellent job gathering together all of the questions. And so, Cass, do you want to read them out or shall I read them from the chat directly?
Feel free to go for it, Sam.
Great. Question, Dan had some great questions. So how do we calculate confidence based on the threshold levels? So our detectors use a combination of different signals to make their detections. That also includes machine learning based classifier models. So these actually output a confidence score. So where we're using machine learning, we have a confidence score there, but we also use other signals. To give you a kind of very simple example, if you were looking for a phone number, if there's a mention of phone number, etc., in the nearby text, that is an example of a signal we will use to increase our confidence. And so, yes, it's mainly based on machine learning models, but we use a range of signals. And so that outputs a confidence score that we then translate into a confidence level. So it's easy for you to understand and use and modify your policies to get the behavior that you need. Another one from Dan. Is regex the only way to create custom policies? Can we also train classifiers within Guard to capture custom scenarios? So at the moment, the custom detectors are just regex based, but allowing you to create classifier models is something that we're working on. So keep an eye out for that. It's something that we'll hopefully be able to offer to you soon. Next, going down the list, we've got how flexible are the custom detectors. So yes, regular expressions allow you to put any kind of text pattern, but you can also put particular strings. One really useful application for them as well is for preventing leaking of system prompts. So we recommend creating a custom detector with your system prompt and possibly even little sections of your system prompt, particularly the sensitive parts. And so you can create a filter there that stops anyone trying to extract that from your model. So anything that you can do with regular expressions, so that's words, strings, patterns, is available. And if you need any help creating those, reach out to us. We can point you in the right direction. And we have some examples in our documentation to make it super easy to create those. Another one, can you background capture the answer from Lakera and put in a logging stream? So whereas the interview can be logged. So we have a full set of logs as part of Guard, and they can be exported into a file location, and we can also then integrate with a SIEM or another security product. So you can basically store the logs in a database and then connect up your security operation, or you can build your own analytics on top. So we've got customers who are using Grafana or kind of other classic analysis tools. And again, this is available with SaaS or self-hosted. So we provide flexibility to basically get those logs and then build whatever you need on top for your security workflows. Another good question from Dan. What will the user experience be when things are detected? So that is entirely up to you. So what Lakera Guard will respond is basically a flagging decision, true or false. And then it's up to you to work out in your application how you want to handle that when we detect a threat. So in the example Matt showed, we had a particular message. You could customize that message. This is also something which is useful to use the Policy Control Center for, because sometimes you might want to block, sometimes you want to just monitor, sometimes you want to check with the user, hey, I've got a link here, this looks a bit suspicious, are you sure? Or be cautious with this. And so, we've got some flexibility there. So it's entirely up to you with delivery design, so you can program around it. Cool. And so we've got time for, I think, 2 more questions. Any more in the chat? I think we've answered most of those. Yes. So, well, I guess, yeah, this is continuing your question, Dan. So, depending on how you've got set up, we log, you can choose whether to log the inputs or not. So if you choose to log the inputs, we will have the jailbreak stored. And so, yeah, you can choose to maintain the state or understand exactly what was sent at the time and do that in the analysis as well. Any last questions? Great. So hopefully that answered everyone. Sorry if I missed anyone. Feel free to reach out if there are any that we missed, and we're happy to answer them afterwards. And if you haven't already, here is the QR code, so you can get out your phones and book a one-on-one demo. And I want to thank you for taking the time. And I look forward to hearing about how you're using Guard to secure your GenAI applications, and hopefully we can build a secure AI future. Thank you, everyone.
Thank you, guys. We're going to be sharing the recording tomorrow. And thank you, Sam. Have a wonderful evening or the rest of your day. Thank you, guys.
Thanks, everyone.